Identify the horizontal asymptote of each rational function. Number 4, g of x equals x minus 3 over x squared minus 4. First of all, we need to factor where we can. So if you look in the denominator, we can factor that out. This is a difference of two squares. So we'll have x minus 3 over, this is going to be x plus 2, x minus 2. This eliminates the middle term, plus 2x minus 2x, so we see there's no middle term here. And the positive 2, negative 2 will give us negative 4 if we were to redistribute this and check ourselves. Okay, so looking at this function, we can see the powers here. Nothing cancels out, like we have a previous example up here where we had the x plus 1's cancel out. That will mean a whole occurs at that point. There's nothing like that happening here. So we just look at the powers of the leading variables. So we have a 2 and we have a 1. When the denominator is larger, or if the numerator is smaller, however you prefer to see it, the horizontal asymptote will always be y equals 0. So if you have a situation where it's x over x squared, or x squared over x cubed, anything like this, where the power on top is smaller than the power on bottom, this is your horizontal asymptote, y equals 0. That's the rule. Okay, moving on to our next example here, just looking at horizontal asymptotes right now. We need to factor this numerator and factor the denominator. So the numerator is going to factor 2, 2x minus 1, and x minus 1. For a factoring review, see one of our videos about factoring. We'll go into more depth there. Over x plus 4, x plus 3. Alright, so again, nothing is canceling out here, so we're looking straight at the powers. So if we see here, the powers are both 2. So when the powers are the same, or when they're equal on the top and the bottom with the leading variable, the horizontal asymptote is going to be the coefficients here. So we have a 2 and we have a 1 here. So the coefficients equal 2 over 1. Therefore, our horizontal asymptote is going to occur at y equals 2. So when the powers are the same, you take the coefficients in front of those powers and reduce the fraction. That is your horizontal asymptote. When the powers on the top are smaller, the y asymptote will always be at 0. Okay, moving on to the third example, number 6. 2x squared plus x over 1 minus x. Okay, so here we have a third and final example of a different horizontal asymptote situation. If the power on top is bigger than the power on bottom, so we see our leading coefficient, our leading variable is still x to the power of 1 here in the bottom. The top is bigger than the bottom. Therefore, there is no asymptote, none. First though, I kind of jumped ahead of myself. Let's see if anything factors out. So we can factor an x out of this, and we will get 2x plus 1. And we can factor a negative 1 out of the bottom, so we can get x in the front here, and get x plus 1. Rearrange this into something a little more familiar. So after we've done this, we see nothing can reduce, but we still see that the powers, there's a squared on the top, just power of 1 on the bottom. So the horizontal asymptote does not exist. There's no asymptote.